Hello, this is Mr. Collier, and today we're looking at intersecting lines in vector form. Okay, first we want to look at the angle between two lines, and for the angle between two lines, we just need to look at the direction vectors. Okay, so to get the angle between there, we use the formula cosine of the angle in between equals the quotient of the dot product of the vectors over the product of their magnitudes. So it's going to be root 2 squared plus 1 squared plus 4 squared, root 0 squared plus 1 squared plus 1 squared. Okay, that's going to be equal to 0 plus 4 is 5 over root 21 root 2. And if we do inverse cosine on our calculator, or arc cosine, we get 39.5 degrees. Okay, next we're going to find a point of intersection. Now these lines, they don't look like they're parallel. And even if they're not parallel, they might not meet up in 3 dimensions, right? They could be skew lines and not meet at all. So to find where they meet, let's just set them equal to each other. So 1, 2, 1, and then we've got minus t plus 2t. So that represents every point on this line. And we'll set it equal to the other one. That should be a minus s. Okay, so we can solve some simultaneous equations. We have 1 minus t equals negative 2 plus s. 2 plus t equals negative 1 plus 2s. We can solve these by adding them together, and the t's cancel. We got 3 equals negative 3 plus 3s. 6 equals 3s, so s equals 2, and if we substitute this back into the equation here, we'll get t equals 1. Okay, so we got that by solving the first two. We do have to, the last one could be different, the last point could be different, and then these lines wouldn't intersect at all. So we can check by checking the last equation. 1 plus 2 times 1, does that equal 5 minus 2? Yes, it does, so it does work. And actually, what do you get from that? You get 3. Well, let's generate a point. We can substitute t into here or s into here to get our point. So let's do the t value. So to calculate the point of intersection of both of them, t is just 1, so we can just do this calculation. To get the point of intersection, it's 0, 3, 3. Okay, if you plug in s equals 2 into this one, you also get 0, 3, 3. So that's the point of intersection of the two. Okay, so sometimes we get skew lines. Let's check to see if these are skew lines or if they meet. They're definitely not parallel because the direction vectors are not scalar multiples of each other. Okay, so we just set them equal to each other, or we just set up some simultaneous equations like 1 plus t equals 2 plus 1s, right? And then this middle one looks pretty interesting because we've got a 0 there, so that we're just going to get, actually we could have just started with that one. But the middle equation is nice because we have 2 plus 0t equals 1 plus s, so s equals 1, we can get that pretty quickly. Plug that into this one. 1 plus t equals 2 plus 1, so t equals 2. And then we can plug it into both of them and see what points they generate and see if they're the same. Or we can test it out in the last one, I suppose. 1 plus t is 2, and then this value is 2. Does that equal 3 plus s is 1? So on the right hand side we got 7, and over here we got 5, so that's not equal. Therefore they are skew. They are not parallel, they are skew. Okay, next we have a Cartesian equation of a line. Let's back it up a bit actually, so we can write this one in Cartesian form by solving for t for all 3 components. So for example, if we write out r as x, y, z, we have x equals 1 plus t, y equals 2 plus 0t, z equals 3 plus 2t, If we solve all of them for t, the first one's going to be t equals x minus 1. And second one we can't solve it for t, right? So in the last one we have 2t equals z minus 3, so t equals z minus 3 over 2. So this one in Cartesian form would be x minus 1 equals z minus 3 over 2. So yeah, we got that by just setting them equal to each other because they're both equal to t, right? In this case we got y equals 2, so usually we'd have a three-way equality, but we just write comma y equals 2, and that's the Cartesian form of that line. Okay? That would be that in Cartesian form. Now if we go over to here, to this one, to put them in parametric form, we can write x plus 1 over 2 equals t, 2y minus 3 over 3 equals t, and 1 minus z equals t. So we get x plus 1 equals 2t, x equals negative 1 plus 2t, and for this one we get 2y minus 3 equals t minus 3, 2y equals t, well, just t, so y equals, wait, no, that's not right, sorry, that's 3t, this is 3t plus 3, divided by 2, we get 3 over, or let's rearrange these, 3 over 2 plus 3 over 2t. And rearranging this one for t, we get, rearranging this one for z, we get z equals 1 minus t. Okay, so that means x, y, z, which equals the vector equation R, equals negative 1, 3 over 2, 1, plus t times 2, 3 over 2, and negative 1. Okay, now remember, for the direction vector, this could be any parallel vector, so you could make it nicer without the fractions by multiplying everything by 2 and write it 4, 3, negative 2.